My name's Lee. I'm a developer on the IBM FHIR server. So the IBM FHIR server is a Java implementation of HL7 FHIR specification. In addition to the server, we also have a number of other modules on our GitHub page at github.com/IBM/FHIR. I'm going to take you through some of those modules and some of the design decisions that we've made that underpin the server, and then I'm going to jump into the features and functions of the server itself. So first, let me jump over to our website where we have a number of guides. So at the core of the project, we have the FHIR model. So HL7 FHIR as a specification defines a number of structure definitions that define the shape of the data for various healthcare interactions. And in addition to defining the structure, they also have metadata for generating code to support reading and writing of those FHIR resources. So our implementation is one of many that uses that code generation approach, but we differentiate ourselves from others through the support in the model for two design patterns, the builder pattern and the visitor pattern. So the builder pattern is a way of building thread-safe, immutable Java objects that represent FHIR data. So here we have an example of building up an observation. The visitor pattern is a quick, efficient way to iterate through this structure, and we use that pattern in really all over the place, from resource serialization to FHIR path evaluation to transaction bundle processing and more. So we really get a lot of utility out of these two patterns, and it makes for a nice object model. So the next thing I'm going to jump into is our validation guide. So one of the key design decisions in our FHIR server is that it's validating by default. So actually baked into the model, when you construct an object, we'll evaluate a number of core constraints from the FHIR specification, such as element cardinality. So like if there's a required element and it's not available in your builder objects at the time you build your FHIR resource, we'll properly alert you to the fact that that is not a valid resource. From there, we have a number of secondary constraints that we evaluate. So this is a picture of how the validation happens and the various components involved. So we already talked about the FHIR model. The FHIR registry is another important component. So this is a module that provides an in-memory registry for conformance artifacts, sometimes called knowledge artifacts. So these are FHIR resources that are not related to any particular instance of care. It's not a request to do something or an action that's been done. Rather, it's sort of a representation of some knowledge. So this is used a lot in FHIR from terminology services. So there's resource types like code systems and value sets, to kind of measures and evaluation of measures. Plan definitions and activity definitions would make up things like, standardized care plans that aren't specific to any particular patient, but kind of it's more like general guidance from which you can instantiate particular care plans for particular patients. And then finally, the registry has metadata resources about FHIR itself, things like structure definitions that define the resource structures, and also extensions. So extensions are built into FHIR and supported fully by our FHIR model. And you can define new extensions, register them through the registry, and the FHIR validation support will actually validate instances against those structure definitions in the registry. If we run into extensions that aren't available in the registry, that will generate a warning saying, sorry, we couldn't validate that. And so it's sort of a best practice to register your extensions so that we can validate against them. All right. Another component to validation is terminology validation. And for this, we have some dedicated support. So we have similar to the registry, it's an extensible model. And built into the server, we have 3 implementations. One that's very mature and robust, and 2 that are less mature, but showing great promise. So the FHIR term service uh, can have a number of providers. So these are the different implementations. And kind of the core one to the server is called the registry term service provider. So this is built on those code systems and value sets that are available in the registry directly. By default, our registry will include all of the courses, all the core FHIR spec artifacts are already available in the registry, as well as we provide ways for you to extend that with implementation guides. And this is a really key important concept in FHIR because the base specification itself is fairly generic, lots of optionality, not a lot of required things. However, kind of the way to achieve interoperability with FHIR is through defining what they call an implementation guide. So this is a way of packaging up those conformance artifacts that I've mentioned before, and there's an emerging standard within the community which is built on the NPM package format, and so each implementation guide will be available as an artifact, and we have a way to kind of quickly and easily extend our registry with those implementation guide artifacts. So the registry term service provider would use those code system and value set artifacts along with the ones from the core specification and allow us to do terminology services on top of those. There's a few limitations on this approach. It really only works for code systems that are small enough to fully represent within a code system object. And so because that's not the case for a number of kind of very large, very important terminologies such as SNOMED CT, we have a couple other implementations to provide services on top of code systems like that. So first there's the graph term service provider. This actually uses the Janus graph project, so it's a graph database that has its own schema that gets loaded with this data, and we implement the terminology services from FHIR on top of that. This is, I'd say, the least mature implementation that we have, but it is a very interesting approach and could have legs if we find the time and resources to really dedicate towards it. What I think is probably a better short-term approach for us is a remote term service provider. So this allows us to work with external terminology services. So SNOMED CT, for example, is the product of SNOMED International, and they actually have their own FHIR service endpoints up. And so you can configure our server to talk directly to that, and we'll utilize that external terminology service as part of our validation with caching to ensure strong performance still. All right, so the next component I was going to mention is our FHIR path. So we implement the HL7 FHIR path 2.0 specification. So FHIR path is a language that's kind of derived or based on XPath. So it's a traversal, selection, extraction, and evaluation language. It's used in 2 main ways by the server. The first is parameter extraction. So this is like when we get a resource into the server, we're going to evaluate all of the search parameter definitions against that resource instance that we get, and that is actually FHIR path under the covers. So we evaluate all the FHIR path expressions, we save the results and make those all indexed and searchable. The second main place that's used is in that validation module I mentioned, which is something we call constraint evaluation. So our FHIR validation implementation is actually very interesting because the core constraints are all kind of supported directly by the model, but the secondary constraints all become FHIR path evaluation. So even profiles that are defined in implementation guides, such as the US core implementation guide might say, for for the US realm, a patient must have a last name. Whereas in the core specification, the patient, may not have a last name. So in in our validator, we'll actually read that constraint from the structure definition and write it out as FHIR path and evaluate that FHIR path constraint when you call the validation engine. All right, so hopefully you can see there's a lot of content and a lot of support here for reading and writing resources as well as validating them. And we haven't really even gotten to the server features yet. So there's years and years of development effort that have gone into this project, and made it really one of the most performing, most capable FHIR implementations that are available on the market. So I guess next I'll mention one more module here, which is the FHIR provider module. So the FHIR provider module is now getting into kind of HTTP web API territory. So what it does is it's a JAX-RS provider. So this is a Java and XML REST services standard. So this is a widely used mechanism, standard for supporting web services out of Java. And it's very extensible, and it lets you define new types of resources from the HTTP sense of the word resource. So FHIR itself defines a couple of media types: application FHIR JSON and application XML application FHIR JSON and application FHIR XML. So we support both of those directly from our model, and the FHIR provider module wraps the kind of generation and serialization of those resources and plugs it into this JAX-RS framework. This is still used and usable from outside the server. So for example, when I implemented support for the smart app launch sequence on our Keycloak instance, I extended the underlying JBoss implementation with this FHIR provider support, and that gave me kind of direct support for reading and writing FHIR resources from JAX-RS. So in addition to the server, we also have a client, and that client module uses the same FHIR provider for reading and writing resources. It wraps, in this case, Apache CXF, which is an implementation of JAX-RS. So we wrap that Apache CXF project, and it gives us kind of a more FHIR native client API as opposed to working directly against the HTTP interface. All right, so I guess with that, it finally brings us to the actual server implementation itself. So let me jump down in our README. So you can see from here the server is available in a number of different types of artifact. So from the releases page, you can get a zip file with an installation script for either Windows, Mac, or Unix. But in addition, we have a Linux container image and a Helm chart. And we've worked really hard to make it very easy to get up and running with these. So that's what I'm going to kind of jump into on today's, the rest of this session. So first, the Docker image that's available from Docker Hub. You can just run this directly. So it's this one command. If you have Docker installed, this will actually create and bootstrap embedded Derby database, which isn't really for production use, but it's really handy to kind of get something up and running real fast. So we had this first, and we had this for a while. It works well. It's a great way to get started. But by default, there's really no persistence because it's that embedded Derby database. And so what we've worked towards is a Helm chart for deploying to Kubernetes, where it's a little more production ready. So our Helm chart actually packages a PostgreSQL subchart, as well as an optional Keycloak subchart. And so the combination of those three, the IBM FHIR server, Keycloak, and Postgres, gives you like a really nice flavor of our capabilities in this area. So let me kind of jump through that, and we'll kind of see how it looks. All right, so let me pull up a terminal here. So the very first step here is to register Helm. So this is assuming you're already targeted at a cluster. So you have a Kubernetes cluster ready to go, and you're ready to target it and deploy to it. So you add the Alviary Helm repo. You generate or create a PostgreSQL password, and then you go ahead and install using a command similar to this. It's kind of a long one. And so what this is doing is it's using almost all of the defaults. Oh, let me get that on screen here. Using almost all the defaults to create and install an instance of the FHIR server together with PostgreSQL. In this case, it does not include that optional Keycloak subchart. So because our Kubernetes cluster is on IBM Cloud and it supports something called Ingress, we're going to set the Ingress values appropriately and go ahead and run this. All right, so I had to go look it up, and in my case, the cluster name is my secret name, and my host name for the cluster is just that, followed by useast.containers.appdomain.com. So let me try giving that a shot. Okay, so what we'll see here is because we asked for the subchart notes, we actually are getting the subchart notes from the PostgreSQL chart first. So here's all the information about the Postgres server that's up. And then followed by that, we have the release for the IBM FHIR server. You can see it gives you a couple helpful suggestions here. So what we're going to do is just get the pods. I have kubectl aliased to my K. So you'll see me kind of use that as a shortcut here. All right, so what that cluster is doing right now is it's creating a persistent volume claim for the PostgreSQL database. And then once that becomes available, it's actually spinning up the PostgreSQL server. And once that is available, we should see the IBM FHIR server schema tool start to run. So this is a standalone tool, and it has its own Docker image that lays down our schema on top of the relational database system, in this case PostgreSQL. Except when I ran that command earlier, I forgot that there's one extra step. So if you're using an Nginx ingress, which we are, you also need to set the backend protocol. So by default, the IBM FHIR server has only HTTPS support. Our HTTP endpoint is actually disabled. There's a way to tell the chart to enable that, but for external access, you definitely will want to be using TLS. So that's what we're going to do here. I'm going to add this to that last command. Let's see, it's a Helm upgrade. So we're just going to add the set for the Nginx ingress annotation to make the backend protocol HTTPS. So this is controlling from the ingress, the entry to the cluster to the FHIR service running inside the cluster. And we'll give this one a try. All right, so we see our same output here. We can see we're back to where we were before. So this will be just a minute here. Now, something that's kind of interesting about our schema tool. So we added support for a lease mechanism so that multiple pods can run at the same time, and only one will be able to update the schema at a time. In addition, our FHIR server pods by default actually won't be up and running in a ready state until the health check is passing. Our health check checks the database connection. And so what we should see as this spins up is once the persistent volume claim is created, the PostgreSQL service will come online, the schema tool will start running, the FHIR server should actually move from an init status to a running status, but it won't be ready until the schema tool completes. So let's see if we can get that all working here. All right, so our PVC is ready. So now the PostgreSQL pod is coming up. I'm gonna put a watch so I don't have to keep running the same command. All right, now our PostgreSQL server is running. And when that goes to ready, then we should see that schema tool start. And also the FHIR server pods are starting. So now our schema tool is laying down our schema. In this case, we're using the default, which supports all resource types. We do have a way of creating just a subset of the resource types in the schema, but by default, you'll get support for all FHIR resource types. All right. There we go. The schema tool now completed, and you can see that our FHIR server pods have moved to a status of ready. That means that they are now able to accept requests, and because we've configured the ingress, we should be able to actually hit it from outside the cluster. So from, for example, from our system here. So by default, we'll get a password of change password. Go ahead and click enter. So we can get our 200 OK from the health check, which is why they're ready. And if we recall, we got a couple ways to check the endpoints here. So one thing that our FHIR server has, which is unique, is it has Swagger definitions built in. So let me jump to a browser. You can see we'll load up a Swagger UI with all the endpoints on the server. All right, now this is a good way to see kind of the breadth of the FHIR API. It's pretty large surface area. Now we have a lot of ways to kind of filter this down to just the subset that you need for your deployment or for your application. But by default, you'll have support for all, I think it's like 140 resource types that are in the FHIR R4 specification. And each of those has a lot of the same endpoints. And so you'll have the ability to search, which is this endpoint, create an alternative for search where you can use post instead of get, so that you can send parameters across in the body instead of on the URL. We can read a particular, read the latest instance of the resource type. We can read a particular version. So in our FHIR server, all resource endpoints are versioned. So what we mean here is if you create an allergy intolerance, that'll be version 1 of that particular ID of that allergy intolerance. And if you update it via a put, then that'll create version 2. So it's just a linear ordering. So VID for us is always going to be an integer, and it just increments. If 2 or more threads are trying to update it at the same time, then the first will succeed and the second will fail with the 409 conflict. So we'll kind of ensure that linear ordering on the resource versions. All right. So you can see, in addition, we have soft delete. We've got the history endpoint. Our server also implements a custom operation for a hard delete. And so that would be like /allergy intolerance /ID $erase. We don't have all of the custom operations in our Swagger definitions at this point, but we do have a few in there. So let me jump to one of those. Oh, actually, hang on. I guess that's in a newer version of it. So this is just, I guess, the REST API. And then in addition to that, HL7 FHIR defines a set of custom operations, and you'll see those will follow a similar pattern, but they'll have a $sign in the path of the last section here, and you can have a named operation that isn't necessarily RESTful. So we use that to support things like import and export of bulk data. You can invoke validate on each resource endpoint. So that would let you kind of just run our validator against a given instance without actually ingesting that. So there's just a lot of capability in this REST API. So it's pretty massive. So I'm going to jump down to the patient resource. Oh, before I do that, there's something called compartment search. So within each resource type that references the patient, there's this alternative syntactic sugar for asking for those resource types as scoped to a particular patient ID. And so in this case, with the account resource, we'd be asking for all of the accounts that belong to the patient with a given ID. All right, let me jump down to a patient endpoint. I think that'll be like this. Patient version. Yeah, okay. So here we are at our patient. All right, so what's kind of interesting is that by default, we'll be using HTTP basic authentication, and there's a username and a password, and those are all configurable. Here, we're going to actually use the Swagger UI to start making invocations against our server. All right, so first, you can see all the different ways that you can search, all the different ways you can search the patient resource, and it's a lot. I'm going to try it out here, and that'll let me actually invoke searches. Now, all of those are optional fields. If you do perform a search without specifying any parameters, you'll just get back all of them. Here, I'm using the FHIR user change password defaults, and I'll be able to invoke that search right against the server. Of course, there's nothing in the server yet, and so we get back an empty response body. Okay, so now let's create our first resource. So, oops, sorry. There's actually two ways to do this. One is via the create API, and one is via the update API. So our server supports what is called create on update or update create. And so you would do a create to the /patient endpoint, and that will create an instance of a patient on the server, and the server will assign it an ID. Alternatively, you can put, which is passing the ID as part of it. So this would be a way to use a client assigned ID. And you have to be a little careful with that one, especially if it's like a more open exchange, because these IDs really do need to be unique. We will not prevent, as long as a client has access to the update operation, we wouldn't prevent them from overriding a particular version of a resource with a different version of a resource, even if it has a different business logical identifier. It's just the resource ID that controls it. Okay, so here's our post to create a patient resource. You can see that this is just doing a minimal a minimal post with really nothing in it, but I can go ahead and do that. See what we get back here is a set of headers, including an E tag, which is the weak version number. So this is version number 1 of this resource, as well as a location that you can use to dereference the created patient. And you can see our server actually assigned it this long ID, which is a GUID, a globally unique identifier with a timestamp prefix. So that's our default on the server if we're generating the IDs. But you are free to, like I said, use this put operation instead. And if you do that, it will look something like this. So we'll try this out. In this case, I'm just going to say this is our patient 1. And you do have to actually set the ID of the resource here as well. To match. There we go. All right, you can see that came back with a 201 created. This is version 1 of this resource, and you can see in the location, it's actually using our client assigned ID, which in this case was patient 1. So now we have 2 instances of a patient on the system. So now we can actually do a search. So let me just scroll up to our search from before, and we'll just invoke the same thing again. And now we should see those 2 patients created. All right, total response in the search set is 2. And here's our first one, which has that long server assigned ID. And here's the second one that has the client assigned ID. All right, so there's a whole lot more you can do with the FHIR API, just the REST API itself. So this is a nice overview from the specification. We encourage you to try it out, see how it goes, and ask us if you have any questions. Thanks.